Another Draft Physics video production. DraftScience here on YouTube. Magnetism, I think, will generally be the subject, so the background image is appropriate. And probably going to be a Ken Wheeler video. And just some sort of argument about perspective, like what you're really trying to explain and what magnets really do, and what you're required to provide as an explanation is, some sort of mechanism, some sort of follow the bouncing ball kind of idea of a cause and effect. Like there's a thing that happens, and like my hand moving is a thing that happens, and there's real physics, not just imaginary physics, not just virtual physics. There has to be some sort of real physical explanation for how the thing called hand is moved. And with magnets, real things happen, real things move, and they move because real events take place, and the idea is to come up with a rational explanation of the event. What are the players? What things act for the net action? The consequence, the effect. So anyway, there's other stuff that's probably worth talking about also, just in the context of trying to have the conversation. So I did send out a couple more emails to physics type people, attempting to get some sort of willingness to give me a price for what it would cost for an hour of their time, that kind of thing. And so far, nobody's. I can't even pay them, which is kind of ironic and funny. So anyway, it was funny on this Ken Wheeler video. The "Wear Me Weed" guy, okay, I kind of insulted. I actually did post a comment on Ken Wheeler's video, so I can't do it, so it's good that somebody does. DraftScience says he would debate you, and Ken Wheeler actually did reply, but the reply is missing now. That's kind of funny. Yeah, it's gone. So he made some crack about me being naked or something, because in the summer I now and then make a video without my shirt on because it's 98 degrees in the house. But anyway, but it just seems so funny coming from somebody like he's apparently prudish about that kind of thing or something. From somebody who makes live videos in the winter, essentially in his underwear in his bed, silk, but anyway, just kind of ironic. So that's the best he could do as a reply, but again, the reply is gone now, which is kind of funny. So we'll see. Keep trying. I mean, Ken says he's, willing to debate, but I'm apparently not a character he's willing to debate. But anyway, I mean, there's no logic to that, right? I mean, the conversation, he shouldn't be afraid of any conversation where he gets to point out the obvious and everything he thinks is so simple and all this other stuff. And so he should take any opportunity. And, the less competent, he should be even, oh, great, he's even less competent. So the fact that he seems to be overtly a coward, you can't deny the facts. So anyway, on to the subject, which is the important part here, is the facts. Right. Kind of a waste of time there.
People send me links to articles all the time, specifically written.
Yes, people send links. Unfortunately, I don't get too much of that, and the links you get are just, I get all the wooey links, to nothing about anything fundamental.
By pseudoscientific academic stooges with PhDs. And there's a prestigious article below, and it said that they figured out magnetism.
Alright, doesn't say any of that. So, it really doesn't say they figured out magnetism. It just has to do with they have a new way of playing with the math of their idea of electron spin and alignment, and it's really just about how ferrous materials become magnets, and the arrangement dynamics. So it's really just about the alignment of what they're already conceding are atoms that have a tendency to be magnetic. So you could just say that there's a bunch of atoms that, by their structure, by their composition of electrons to protons, they have an imbalance natively. And the idea is that you can arrange these atoms in such a way as that imbalance ends up all creating orientations with all the atoms where the orientations line up. So the atoms can be in different geometries, and the theory is that there is some mathematical way that you can jiggle these things in just the right way and create energy inside of the system that will end up getting them all to point in the same direction, and that once they are all pointed in that direction with no impurities. See, the trick is that any empty space, any defect in the matrix, so you could say that this is an atom still spinning or turning or still has motion or energy in it, and it will spread that to these other elements and cause them to go sideways, and this defeats your polarization, because you're trying to get all the pluses pointing in one direction, all the minuses pointing in the other direction of the individual atoms. And so this gets into a whole thermal argument, because magnets are very sensitive to heat, and their condition of how these atoms exist needs to be liquid. It needs to be capable of moving, so you have to have enough heat to move them, and then you have to essentially try to freeze them in that condition, or in a condition where they don't have anything in the inside that's going to break the tendency, the will to line up. So I don't know exactly how to create a perfect analogy for this. It's just kind of like when you're lining up stuff and you shake a container to try to filter, like all the big things end up in one location, all the light things. So a little bit of motion or agitation helps you filter out the noise. So if there was like a bad bit in here and you create enough heat, then this bad bit will be kind of allowed shaken out of that position, and you get all the bad bits, all the ones that aren't playing along on the outside, and you have a nice rigid thing in the inside. Then the magnet can remain permanently magnet, then the iron can remain permanently magnetized. So it's not only getting them aligned, but it's like getting them very well aligned. And my argument, as I've sort of pointed out, that obviously the alignment involves something a little bit complex, in that the alignment requires the magnets to be staggered. That is, the plus end and the minus end of the next row have to be next to each other for the condition to be something that's I should just draw them as squares, I suppose, and you could sort of understand that the x1 needs to start where the y1 on the other side, so you have to stagger them in their positions so they'll stick to each other, align in a way that's permanent. So the two sides, these two can't be lined up right next to each other, or they won't stick. But you could understand, if I started to slide this atom up, I would start ending up having positive against positive and negative against negative, and the magnet would tend to tilt out and start to break the pattern. So every time I try to shove a new piece in, I end up sliding that, And if I don't slide it really fast, you could sort of understand that if I don't slide it really fast, this magnet's going to end up repelling this magnet, and it's going to push this one out, and it's going to start breaking your symmetry, because you're going to have movement in the wrong direction. And so it's just about getting that alignment right, so you can sort of understand if once you have them getting you got a bunch of them going the right way, that if you sort of jiggled it, that they'd all kind of fill in the gaps and get more and more solid. And so that's why, like, if you're magnetizing a piece of steel, if you hit the steel, vibrate it, okay, you'll make that cleaner. The magnetism will line up better. You'll help them all line up in the right arrangement, and then it can become a permanent magnet. But if you don't do that, then all of this is quite flexible. If you leave enough uncooperative elements inside, or misaligned elements inside, those misaligned elements will sit there and agitate all of these things. They'll push them out of alignment and cause more defects in all the others. So any impurity caught in the inside tends to just break everything else that's around it. And so then the magnetism isn't permanent. All right, so I think it's probably more complex a piece of the puzzle that needs to be pointed out here. But this is, again, when the conventional people think the magnetism has something to do with spin. So they think it's all the electrons have their orbit, and that the ones are orbiting that way are somehow negative north side magnets, and somehow if they're orbiting this way, they're south side electrons or some kind of crap like that. And so they're lining up spins of electrons, but there is no spin. The electron isn't spinning, and it's not orbiting either. So neither one of those explanations has anything to do with the reality. There's certainly a correlation between the electron's arrangement, its connection to the proton, and how you arrange the atoms, but it really doesn't have anything to do with anything called a spin.
I read the article 3 times. I'll put a link below to this article.
I don't know how you could misparaphrase it so badly. If you read it 3 times, you're making claims that they're not really making.
For you. And it's full of, not my opinion or my feeling or my belief, it's full of so much self-contradictory nonsense. It's not even...
All right, well, he's not going to point out the contradictions. Just pause for a moment here. All right, should be back and such. Continuing, I guess.
Funny, but I'll just even use one of their annotated diagrams here below. And by the way, of course, I'm working on the 4th edition of my book on...
And yeah, use it for what? Anyway, so yeah, the diagram's totally uninteresting. The article's totally uninteresting, blah, blah, blah. But anyway, continuing.
Covering the Missing Secrets of Magnetism, easily the most popular book I've ever written. Not any of my, ancient Greek or Pali translations, but the book on...
Popular based on what? So I can not... no evidence of the extent or meaning of this popularity. What scientist, what thinking person thinks it's a great book? That would be interesting to see. Let's measure the IQs of the people who think it's a great book. Let's do a survey.
Field theory. I mean, of course, the only reason why the visible universe exists is due to magnetism only.
So, whatever that even means, right? He knows it's an emergent phenomenon, and he'll say it's the thing. So, yeah, it really depends on how you look at it, right? I mean, obviously a magnet's made out of dipoles. So you could sort of argue that if we're going to be accurate, you have to say that the monopoles of the magnet are the elemental thing. And no one wants to call those monopoles the electron and the proton, but obviously that's the thing, charge. Charge is the elemental function. And how do you make this idea of something that's inversely related as protons and electrons are? Right? I mean, I can have one field. If I put an electron in the field, the electron moves away. If I put a proton in the field, the proton moves towards. And I can just inverse the field, and the exact opposite thing will happen. So there's this inverse relationship between the two things. that is, everything else is a manifestation of that attraction and repulsion.
But I mean, the nonsensical BS that is in this article is absolutely fantastical. And I don't mean that in a complimentary sense. It's fantastically absurd. I mean, it's on the level of unicorns and leprechauns as far as explanations go.
Well, it's just as vacuous as yours in some respects, in the sense that it just talks about things like the electron spin, and just as a replacement for the mechanism. But we know the mechanism has to do with alignment of electrons and protons. The dipoles align, and that makes the material magnetic. If the dipoles are pointing in different directions, it's not magnetic. It's kind of that simple. And again, the whole article really was just based on ferromagnetism. It wasn't discussing all forms of magnetism.
And I do mean this succinctly, and I've done it a few times. If you go up to any professor of physics or any professor of astrophenomena and say, this is a really simple question. What is a magnet by definition?
Right, and they'll explain to you a magnet. They'll talk about domains and the alignment of the dipole moments of electrons and protons. That really wasn't in the article, actually. It was really just a spin argument. But they would use some words like that to describe that atoms have a polarity, and that when you align all the polarities, the phenomenon of becoming, the material becoming magnetic, in the sense that it's creating something different at one end than it's creating at the other end, happens. And they're perfectly comfortable explaining that. Now, your better question that he asks sometimes is, what is a field? That's a better thing to ask them. But people can do the same thing to Ken and just say, what's an ether?
Definition. They actually can't give you an explanation, and I've said countless times in countless different videos, it's okay not to know the explanation or the answers to things, but it's succinctly accurate to state that no one has ever gone looking for the answers to something that they already think that they know the answers to.
Well, so again, the argument isn't so much that they already know the answer. The argument is that they've had the history, and the history sort of says certain things that they've accepted as, yes, probabilistically right. And they're afraid to change any of those Faraday or Maxwellian assumptions, because that requires a whole bunch of other stuff to change. But I think they are looking. That's why they're writing articles about little tiny nuance of something they figure out, that you can influence it by doing a certain thing, or there's a certain probabilistic time period, you could almost argue, or some other kind of thing to describe how much you have to shake the cup of sand to get the big pieces to go down and the little pieces to come up, or vice versa.
And it's absolutely ludicrous. What defines a magnet, since let's say both of these are exactly the same thing. Here we actually have the neodymium.
So I don't know why he says this thing, because this thing is a silly thing to say. But anyway, yeah, just setting you up for it. This is silly. So he has 4,000 magnets, and yet he has to use rocks as examples. It is, kind of funny.
Iron, these are stones, of course, they're not magnets. Neodymium, iron, boron, ceramic, composite. Before it becomes a magnet. In other words, it's just a lump of ceramic metal composed of neodymium, iron, boron. And here we actually have...
Well, what I suppose it really is a ceramic that's holding the bits together, but the bits are different materials. It's a matrix of different compounds. It's not one compound. But anyway, continue.
What we call the magnet, which would be the exact same object after it becomes a magnet.
So he says they're the exact same object after it becomes a magnet. That's like me saying, like physics might say, I could throw these scissors, and that the scissors are the exact same scissors, when they're moving after I throw them, and they're the same as when they're standing here still. And I would argue that they're not, that you've changed the matter, because the matter has to be doing the moving. And the same is true for magnetism, is the simple argument that, yeah, it's the same atoms, but you've changed the way the atoms are arranged. just like he often uses ice, water, and steam as an example of the same thing, just different forms. Well, the different form is a substantial difference in that the ice takes up more volume when it's frozen, and it can crush things. It's completely different, kind of, when it's frozen than when it's liquid, in the sense that the atoms are arranged completely differently. I mean, it's silly to say there's no difference.
Well, since there's no quantitative difference, then what?
Well, yeah, there is a quantitative difference. The difference is in the alignment of the atoms, the arrangement of them. Water, it's frozen water. There's an argument that it's, they go kind of geometrically circular, and that's why they expand, is because they're trapping less density inside, blah, 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 little air bits and such.
Therefore, is it that is the qualitative nature that defines the magnet before it becomes a magnet to after it becomes a magnet? And that really simple question literally confounds people.
Okay, it doesn't do that. So I don't know. See, this is the kind of thing he says. He says this stuff, but he's never demonstrated that anybody who knows anything at all about even high school science would it be at all, have any trouble at all in explaining the difference between the iron before it's magnetized and the iron after it's magnetized. And they would certainly be able to say, well, I think it has something to do with the arrangement of the atoms. They're lined up differently. I mean, come on. I mean, he's just so full of preposterous exaggerations and made up stories.
And it's okay, like I said, not to know the answer, but these scientists, and I do mean all of them essentially, they'll say, we know what a magnet is. Sure we did. It's like, are you sure?
No, they don't say that, but the point is they know that their electrodynamics and quantum theory is somehow right. And so even though it doesn't provide them with any kind of clear mechanism to describe how a magnet works, because they can't account for the energy, they can't account for the force and where it's coming from. It's a fact. They can't account for it because they don't consider the universe to be full of force, simply. And neither do you, Ken.
People tell me, it's like, sure we know it, man, because they're in our cell phones, they're in computers. We know what defines a magnet. It's like, well, if you know what it is, then you should give me the answer for it. And they can't do it.
Right. That's sort of illustrated in the article, is where they're pointing out how these are tough questions for them to answer, and so they have a little clue now because they have some math that figures out a geometry that works where they can make all these domains line up. Well, inside, where they can make all these magnetic moments of the electrons, their spins, to line up. So they figured out a mathematical system where you can agitate them with a broken bit, by moving it around in the matrix in a certain way. Then you can you can get rid of the aberrant bits and create alignment. Hard to explain exactly, but I mean it's just this idea of there's a right way to shake something to filter stuff out in a wrong way. It's like if I was to pour ink into a fluid, it's almost like making an argument that there's a mathematical way I could stir it where the ink went back up and stayed in a little puddle. There is probably math for that phenomenon, where it doesn't mix because you create a circumstance where it's spinning in such a way that it can't mix. That part ends up just coalescing.
I would like you to check out this article below. This article actually made me feel good because I'm looking at this, I'm always crushing my brain working on this book, and I've got literally hundreds and hundreds of pages of notes to add to the fourth edition, excuse me. There has to be ultimately 6 editions of my book on magnet.
Right, there has to be 6 editions for some reason. So he keeps saying he's simplex and he knows it, and yet he has to keep making additions. If you know it and you've got it nailed, why are you worrying about making additions? Why you need to make additions? What are they for? If it's so simple.
And I read this nonsensical garbage, and it just makes me laugh. And right here in one of their diagrams, it says an atom with no magnetic field. There's no such thing as something that has no magnetic field.
So that's not what the article is really saying. It's just saying that one of these, it's almost like the noise, the impurity argument in conductors, that the impurities are what creates a lot of havoc in how electricity goes through a wire and why there's an inefficiency. And if you can get rid of the impurities, their influence, you get rid of, heat. And the same thing is true for this magnet. It's just these little bits that are not playing, that are the ones that are the problem. And so, anyway, he's taking that little bit out of context. The article wasn't saying anything like that. All it was saying is that there's this little, the idea is that you can have an ion in a whole set of atoms, and the place where there's a missing electron can be moved around almost anywhere in the circumstance. And every time you move the place where there's no electron, all the other electrons fill that void and create a new void somewhere else. And by moving the void, you can rearrange everything in the picture. So they analogize it to one of those little slide games where you have 4 rows of squares, and you have one that's out, and you can move all the other squares by moving them into the empty space, and move the empty space all around and spell names or something.
Something is diamagnetic, paramagnetic, or ferromagnetic. Everything is magnetic. I've shown that the most diamagnetic element in the universe, bismuth, is magnetoreactive. But of course,
magnetoreactive. So again, bismuth isn't the most unmagnetic. It's the most paramagnetic, right? Or whatever the argument is. It creates the best opposite field. But regardless, so the most unmagnetic is probably something like, I don't know, peanut butter. I mean, there's lots of molecules and lots of atoms that don't have polarity, where they're balanced. Their electrons to their protons creates a balance, and they're as much negative as they are positive.
of course, people don't understand what so-called magnetic attraction is, and there's no such thing as magnetic attraction, by the way, and so-called magnetic repulsion. But they also...
So he says there's no attraction. I don't know. Is he also saying there's no repulsion, right? So it's just silly to say that, just because the words are just used to describe the effect. And the effect is that things move towards and things move away. There's obviously repulsion and attraction. The point he should make is that, either it's an inverted attraction or it's an inverted repulsion. There's a push or a pull mechanism, and the obvious answer would be push. Pull is silly. Elemental things can't pull.
I can't give you the definition of what defines a magnet. What defines a magnet is point source incommensurability. It's the exact same.
Right, so that's supposed to mean something to, like I said, even the scientific literate aren't going to understand what that jargon means. Point source commensurability. What is that? That's not saying anything. It's not a coherent sentence in any room full of any group of people except whack jobs looking for unicorns. I mean, you've got the unicorn theory, Ken. I mean, that's just such jargon.
Thing that distinguishes a perfect analogy, thank you very much, saying that to myself, defines the difference between a 5-watt light bulb and a 5-watt laser.
So again, this moronic statement. It's the difference between, I don't know, let's see, shooting, you're going to try to kill somebody and you shoot bullets straight up in the air and you shoot them over there and you shoot them over there. You're not very effective as a murderer if you don't shoot the bullets at the target. The difference between a 5-watt light bulb and a 5-watt laser is just the fact that you're taking all of the energy and you're shooting it in one single direction, in one single little bit of area. And that's the only difference there is. Same energy. You're just pointing it all one place in one case and not pointing it in one place in the other. You're spreading it out. I mean, it's so obvious. It's like a pressure argument, right? I mean, I can be hit by, atmospheric pressure and 15 pounds or whatever it is per square inch. Well, what if I put all of the pressure on one tiny spot on my body? Well, then it's going to drill a hole through me.
You say that to the common person that's not scientifically or logically minded and say, what's the difference? A 5-watt light bulb is pretty useless, and these are a lot brighter than 5 watts. They're illuminating my face.
I mean, it's useless for what? Laser beams are pretty useless for making videos, right? I mean, if you just have a laser beam in the room and it just shines on whatever, your left breast eye, It's not going to do too many people much good, is it? It's not going to be very effective at illuminating the entire video area, is it? No, it isn't. Yes, they have different functions.
5-watt laser will burn a hole in your ass, right? It's dangerous. I've got a 5-watt blue laser. It's really friggin' dangerous.
I don't know if he actually has a 5-watt. I think he might have a 5 milliwatt laser, but whatever. No need to argue such details. I don't think.
That's dangerous where he has a 5-watt light bulb is useless. Well, 5 watts is 5 watts, right? What's that point source incommensurability? The actual same distinguishment between the qualitative nature, not
point source incommensurability. I mean, again, what does that jargon mean? What are you talking about? I mean, like I said, you're just pretending. Okay, that's being scientifically literate. Is that jargon? What book do I go to see that written down in?
the quantitative nature of a 5-watt laser versus a 5-watt light bulb. Since they're both light and they're both emitting 5 watts, both have 5 watts of power that's powering the illumination. What's the distinguishing difference qualitatively? And it's the exact same qualitative difference, the point source incommensurability that defines a magnet. People will say, well...
So again, it's obviously this doesn't have anything to do with the truth. So he's arguing that somehow the magnet is focusing, the energy or redirecting energy into just one place, when no, all it's doing is changing the nature of it. There's the same amount of energy. The atoms are reflecting and emitting and interacting with the universe in exactly with the same amount, and all they've done is one side is reflecting all proton reflective force and one end is reflecting all electron reflective force. The force that that makes electrons move away and the force that makes protons move away. They're two different forces. It's the only way to make the thing add up and work. And so that's all you're doing. You're just filtering it. You're taking purple and you're making blue and you're making red, and you're making the blue go out one end and the red go out the other.
Well, the domains are aligned. Well, that's a description. Well, of course the domains are aligned in a magnet, but that does not denote...
Of course they are. So you just did the rock thing. When you held the two rocks, you didn't talk about how the domains fundamentally change. The magnetized rock has domains that are aligned, and the unmagnetized rock doesn't have domains that are aligned. It's a qualitative, real difference. So why are you pretending there's no difference? It's the same thing. It's not the same thing. You're conceding the existence of domains and their alignment. So this is where you're the one contradicting yourself.
Of what the nature of a magnet is. And I do mean this literally, not figuratively. If you ask a scientist, what is the hardcore definition of what a magnet is? This is before it becomes a magnet, and it is quantitatively 100% identical after it becomes a magnet.
So he says 100% identical. He just said domains. He just said, of course, domains align. Well, what do you think the domains are? They're in that rock. And the aligned domains are fundamentally and qualitatively different than unaligned ones. I mean, having a bunch of atoms pointing this way and this way and this way and that way is fundamentally different than all of them pointing this way. It's a qualitative difference, Ken.
So therefore, the only distinction between this and this is a qualitative difference. What is that qualitative difference that defines a magnet? And
really annoying.
Can we just order a pizza?
Already done.
How'd you order so fast? How did you find such a cool place to stay?
And they don't know. And it's okay not to know, but they go around telling everybody that they do. And they don't have the answer for that. They literally don't. It's not like I'm ignoring their answer or I'm saying the same thing.
So he just said they don't have an answer when, yes, their answer is there's atoms. Atoms are in domains, and the atoms line up, and the domains end up having to line up. So there's, groups, and the groups have to have all the soldiers pointing in the right way. The little platoons all have to be lined up facing the same direction. And then the domains themselves, the platoons, can be all lined up, but they can be misarranged. And so the crystals of the metal also have to turn and align.
In a different way, they don't know. There's no such thing as an atom with no magnetic field, like it says here in this academic...
It doesn't say an atom with no magnetic field, so that's just coarse shit. So You can say it says it doesn't say that. It really doesn't. So let's go to the article. There's no way it says that. The article doesn't have anything to do with that. And like I said, it's an inset into the article, the image. Okay, so iron and other materials can form permanent magnets like the kind that stick to a refrigerator. The magnetic properties of these materials emerge from the behavior of electrons inside. Okay, tiny magnets. Every electron is like a tiny bar magnet. No, every atom is. I mean, that's the funniest part. Every electron is like a bar magnet. Does that make any sense to you people? I mean, do you really think there's two poles on an electron? What would they be made out of, these two magical poles? Poles of what? I mean, it's just so... It's hard to imagine that they've actually done this. They've turned electrons into a dipole when electrons are obviously a charged monopole. Anyway, the direction of the magnetic field is directly related to properties of the electron called spin. So this is the magical spin that they won't even account for. It's not really spin, it's just a property we made up, and we call it spin. And the property is somehow an electron is a dipole magnet, when obviously no, electrons are dipole magnets. Anyway, non-magnetic materials have electrons that come in pairs. These pairs always have spins that point in opposite directions. The resulting opposing magnetic field cancels each other out. It's just saying coming in pairs just means that obviously if an atom's going to have symmetry, it has to have a symmetrical number of electrons. It can't have an asymmetrical number, or one side is going to be lopsided, kind of obviously, right? If there's 7 electrons on this side and 7 on that side, it works. But if there's 8 on this side, well, then it's obviously a polar atom. Amazing. Anyway, magnetic materials have a few unpaired electrons in their outer orbits. These unpaired electrons generate the weak magnetic field. Okay, let's see. What else is that? Where did he get this crap from? Unpaired electrons in the ferromagnetic tend to align with their neighbors, forming a magnetic domains. Originally, domains don't align with one another, since doing so would create overall magnetic field, which takes energy. Well, they say it takes energy. All it takes is energy in the right way, in the sense that you could just take the normal amount of heat, but if you apply the heat in the right way, it's like rolling dice. If you roll the dice the right way, you'll come up with a 7. You know, it just will happen. But it's just hard to roll them the right way. Anyway, but outside forces can push the domains into alignment. So where did he get this from? Where did he get this atoms bullshit? Because I don't see it anywhere in that. I think that's what he was showing. I don't think there's any other important graphics here. I mean, it's certainly not in this part. Like assembling themselves into bridges and water molecules swirling spontaneously in a system of elements. The answer often depends on some other kind of crap. So yeah, so this is sort of bullshit. Alright, it is bullshit. I thought it was bullshit, so I don't know where he's getting that quote from. Anyway, because I don't see it anywhere. When the numbers are replaced by spins of electrons, the puzzle can be used to explain how permanent magnets work. Whatever. So yeah, I don't see it. So, I mean, that looks like what I just read. Did I read anywhere in there about the atoms, nonpolar atoms? They're talking about electrons.
Paper? It's ridiculous. Paramagnetic, diamagnetic, or ferromagnetic makes no distinction. Everything is magnetoreactive. Every atom...
So he says that crap again. Again, the article was exclusively about ferromagnetism, not any of the other kinds of magnetic phenomena.
And this is where the scientists are correct, partially so. They've been telling you and me since high school and college that every atom is 99.99999% empty space. It's kind of like a super tiny BB inside of a super huge balloon.
Yeah, I don't think they are right about that at all. The electrons can't be as small as they claim them to be. We should never be able to hit one. So I think that notion is completely felonious. Like the sun and the earth, these things have a density. All right, electrons are fluffy. Okay, they're light, but they're huge, and electrons are heavy and they're small. So like the Earth-Sun kind of comparison, the Earth per square meter is much more dense than the Sun is. I mean, a lot more dense.
Which is very, very crudely, conceptually accurate, but what is the air inside of that balloon? Well, the answer is that every atom is a dynamo. And the air of that balloon that makes up the radius and measured in picometers of each and every atom, whether that be small radius or big radius, is magnetodielectricity.
Okay, magnetodielectricity. So inside the atom is a bunch of magnetodielectricity, and somehow the magnetodielectricity is doing something related to the pieces inside. See, he doesn't claim electrons exist, so all he has is protons. And he thinks neutrons are protons without anything else, just protons. I mean, it doesn't make any sense. How does the proton create a magnet, a dipole?
There's no such thing as a magnet that has an atom that has no magnetic field. This is ridiculous.
An atom that has no magnetic field. So he said again, I just don't know where he got it from. Because it doesn't say that.
This whole paper is just riddled. This very, very prestigious academic paper is riddled with nonsense, rubbish, self-contradictory foolishness. It literally is just foolishness.
All right. So I think because the paper made a distinction between materials that are magnetic, that can be magnetized, and materials that can't. And they made this simple argument that has to do with the atoms. The atoms have the wrong number of electrons. You aren't going to be able to make a dipole, an imbalance. You're not going to be able to create the imbalance you need to create a polar atom. You need a polar atom to create a magnet.
They're trying to define to you what a magnet is, and maybe the very caption of this one, it says how magnets work. Well, this doesn't tell you how magnets work. It doesn't even tell you what magnetism is. Magnetism is, of course,
well, yeah, it does, but it's a silly explanation. It's basically saying magnetism is a phenomenon of the spin of electrons, because electrons are somehow magnetic dipoles, and they can go north-south, north-south, and create north this way, and then they can create south going that way because they have north-south in them. Even though there's absolutely no evidence electrons have any dipole inside of them, or that you can take a bunch of electrons and make a magnet out of a bunch of electrons. You can't do it. It's silly. Who thinks that? Do people really think that if I take a bunch of electrons, all by them, no protons, just electrons, and I spin them the right way, I've made a magnet?
ether perturbation modality, no different than dielectricity, no different than electricity, which is...
So the ether modality stuff, I guess I could go on a little bit about that. Look, I really don't want to have a fight with etherists because it's, there's no point. The argument is what is the carrier for momentum? We know momentum goes from one place to another, point A to point B. And this idea of filling the space with some sort of ether to do the job is just superfluous to the function. I mean, yes, you could fill the whole universe with a bunch of things connected to each other, and you could say movement is I banged into this guy and he got big for a second, and then he gives the bigness to this one and goes back to being small again. And so the bigness just travels through a bunch of little bits. Now, the problem with that theory is you can't create vectors in any direction, okay, because there's going to be a geometry you're stuck with. And then you're going to end up with diagonals in your geometry, which are going to be further away. This distance is going to be longer than this distance. And that's going to make the whole thing kind of sloppy and messy. So why bother? Why not just recognize that, yes, what's really happening is there's a thing called momentum, not perturbation, momentum. And it's carried by a thing that has a constant velocity in the universe, the speed of light, and that these little bits of momentum go from point A to point B. And they do it in a straight line. And the only time they do anything different, the only thing where you change them is to stick a piece of matter, an electron, in their way and have them hit it and create differences in the momentum, in the sense that the thing you hit will acquire the momentum and you will, in fact, preserve the energy, conserve the energy and that nothing ever can, there's no real friction anywhere in the real universe, because all the friction we see is fake, in the sense that when the ball rolls on the floor or something, the floor gets hot. It's absorbing the energy. The energy didn't die. The energy wasn't used up. The energy was transferred from one place to another place and to another place. And yeah, because we don't have use for that, we say the energy died, but the energy didn't die. But I mean, the ether is superfluous. You don't need it. It just gets in the way.
It's a hybrid of dielectricity and magnetism. Phi times psi equals cube length of electrification. These are just different pressure.
So how do you even argue with that? Psi times phi equals Planck of an electrification. What the hell is that? So that's an explanation. You want to draw your psi plus phi Planck of electrification is doing something? How does it explain what we see in the real world, which is everything that moves has to be forced to move? No psi plus phi, blah, 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 blah. No, that doesn't want doing it.
Modality expressions, whether they be circular, linear, longitudinal, transverse, toroidal, or hyperboloidal, just like
hyperoidal. So again, all of this stuff moving, and all of it moving in crooked lines, because somehow it knows to move in crooked lines. So somehow the ether knows to perturbate in crooked lines. How does it know that?
ice, water, and steam. Ice, water, and steam are just different temperature and pressure modalities of water, right?
They're not just, I mean, they're substantially different configuration of the atoms. You know, being in a circle versus being aligned up in straight lines, versus being all mixed up and agitated because there's a bunch of heat, a bunch of energy caught between them, bouncing into them and forcing them to keep moving. Those are very different things, not the same thing.
Distinction between ice, water, and steam are just three different things that are given different names due to their temperature and pressure modality states of it.
No, given to the fact that they're fundamentally changed. We wouldn't bother giving them a different name if they were fundamentally unchanged. Okay, if I made a clone of Ken Wheeler and the only difference is one of them has 6 hairs in his ear and the other one has 7, who cares? No one's going to be terribly interested in naming them different things. But if I make one substantially different, then we'll bother saying, well, that's Ken 1 and that's Ken 2, because they're pretty different.
Existence. The same is true of magnetism and dielectricity. I tell you this not superficially, but very, very deeply, that these idiots do not know what a magnet is.
And neither do you, Ken. It's the simple truth. Yes, they don't know, and you don't know. You have no coherent mechanism. You can't explain it simply. You can't draw it simply. I can.
Is what defines a magnet, nor do they know what magnetism is. I love reading these articles because it cheers me up. And I roll my eyes like, my God, these people are so stupid. There's some images of some PhD, postdoctoral, folks that are working for these people don't know anything. They literally don't know anything.
I mean, probably should point out, yes, the article is written by a woman. But whatever. Yeah, it's pretty much just, it's a silly little math trick. It really doesn't have any applicability. It even says in the article, this only works in a perfect simulation. It doesn't work when they try to apply it to the real world. Because, yes, their system of arrangement does take energy. And obviously, magnets don't require any consumption of anything very special in terms of any extra energy. All they're required to be is in the presence of another magnet and the atoms line up.
Anything. And it actually tickles me to read stuff like this. I just, my God. When I came to the part where it said, an atom with no magnetic field, that's ridiculous.
So again, I couldn't find that part.
That is about as ridiculous as it gets. There's no such thing as any... That's ridiculous. That's like saying a mass that has no mass. When you say an atom...
Well, again, the idea that there's atoms that are balanced, that is, their configuration has the pluses and minuses are so well arranged that there's an equal, from a distance, anything would just say, yes, there's an equal amount of attraction to repulsion. There's, no matter where I go around the atom, it's always the same equal amount. Yes, there's symmetrical atoms and then there's asymmetrical atoms.
atom with no magnetic field, that's like saying a mass that has no mass. It's completely ridiculous. They'll talk about magnetic moments, but magnetic moments are descriptive. They're not denotative, nor do they actually define what something is.
Well, you can't possibly have anything called a magnetic moment because you don't believe in electrons anyway. So you're saying protons somehow are magnetic momenting. How would they do this moment anyway? Why don't you tell me, Ken? What's a magnetic moment? Electrons don't have a magnetic moment. Electrons move in, move out of an atom. They change position. And so when they change position from different places, it can look different, right? If I have an atom that's polarized and I move the atom back and forth, well, obviously at any one moment, the magnetism is going to be pointing in different directions. So if I'm only looking from one perspective, well, I'd say, oh, it's only 1/100th of a magnet because it's only a magnet this one moment.
Nor can these people define what is magnetism. What defines what a magnet is or is not.
Yes, those people can't. I can, Ken. I can argue your physics, I can argue their physics, and I can argue my physics. And I can point out to you how you and them are stupid and I'm smart.
They are literally brain-locked into...
Yes, and you're likewise just a devotee of a religion. You just have your psi plus phi of electrification, you have all your jargon, your commensurability, your bullshit terms, and that's all you have. All you have is a bunch of bullshit terms, and you just play with them. And the little dupes who don't know anything about anything, who if we gave them a test, they probably couldn't pass a high school physics test, a high school chemistry test, a high school biology test. They probably can't pass one. I'd say 90% of them can't. I'd put real money on the bet. If it was a place in Vegas to go bet on how dumb your audience is, I'll place the bet. Because they're dumb. Really dumb.
atomistic thinking. And I've never, by the way, a lot of people misconstrue what I say. I've never denied nuclear particles.
Yeah, except all the ones that are important. Yeah. He's going to say it. It's out of its own mouth. I mean, I don't deny nuclear particles except all the ones that are relevant.
Protons and neutrons. But all free neutrons become protons, and therefore...
So all free neutrons become protons. So even though they have a different mass when they're neutrons, they just turn into a proton, and the different mass is just thrown away. The electron. That's what the other thing is. The other little bit of mass is the electron. But let's just pretend Ken's, so a neutron's a proton, except we just called it the wrong thing. It's a proton that's really tired. It's anemic. It's a vegetarian proton. Yeah, it's crippled by its lack of B12 and it can't function. I bet 50% of his audience thinks that's a realistic description of reality. Yeah, them is anemic protons.
Since all free neutrons become protons, then therefore necessitatively there's only one fundamental particle. And I am not...
So there's only one fundamental particle, even though there's two fundamental functions, and they're completely inverse. And so protons are... yeah, so I can't even say anything, right? He doesn't accept the existence of charge. You can't have charge without electrons, Ken. There's just no way to have it. It can't happen. Where's it coming from? If electrons aren't... What are you saying? Protons are repelled by the north side of the magnet and protons are repelled by the south side of the magnet? I mean, it's... you have to have the other piece of the puzzle. You can't have the positive thing and there's no negative thing. That doesn't work.
The first person to say, there's a whole slew of the brightest minds who ever lived that said there's no such thing as an electron.
Right, so the brightest minds that ever lived were 100 years ago, where they didn't have like half of the technology we have now, not even a quarter of it. Not even a tenth of the technology we have now. They didn't have automobiles, didn't have cars. Well, cars are the same thing. Airplanes, all that stuff, light bulbs, none of that stuff even discovered yet. Yet they know the truth.
Particle. Tesla said it. James Clerk Maxwell said it. Oliver Heaviside said it. He called it psychosis. People who believed in electron particles. Eric Dollard said it.
And what did he replace it with?
Walter Russell said it. There's no such thing as a charge.
Religious kook. So yeah, whatever. So there's no charge. I mean, you can't have charge without the. I mean, the electron and the proton aren't the charge carrier, so you can't even get this jargon right. Charge carriers are called virtual photons. The thing that is charged is the electron and the proton. They're the things that have charge as their fundamental property. They are charge.
Particle. Completely ridiculous.
Right, so where's your negative then? What's the negative element? You have protons, they're positive. Where's the negative element?
These people are just completely lost in a sea of their own stupidity. This is what Nikola Tesla meant when he said that there are those who can think deeply.
Nikola Tesla, a guy who never wrote anything. Okay, he wrote a little like kid's biography of his life where he talked about, his first experience, whatever, rubbing his belly. I mean, there was so little physics in it. He wrote absolutely nothing. I mean, he wrote some technical stuff in his patents, and other than that, nothing. Absolutely nothing on the subject of physics.
Meaning mathematicians. This is what Nikola Tesla meant, by the way. He's talking about people that can think deeply. He meant people that are doing math in their head and they're sitting there at the top. That's deep thinking is not the same thing as clear thinking, nor are the two connected. He said there are people that can think deeply, but they can't think clearly. They're quite insane. Quote, unquote, Nikola Tesla.
Quote, unquote, bankruptcy, Nikola Tesla. I mean, quote, unquote, the thing didn't work, Nikola Tesla. It's just a fact. He was wrong. His theory was wrong. That's why his tower didn't work. It's because his theory was wrong.
These are the people that Nikola Tesla was referring to. Deep thinkers, but they cannot think clearly. Because insane asylums are full of deep thinkers. They're great at chess. They can do trigonometry, standing on their head, half drunk. But they're insane. And they're insane for a reason. They cannot think clearly. These are academic stooges that...
So, well, whatever all this crap is, right? So the fact that people can do some things and can't do other things. Some people can play the piano and they can't tie their shoes. Facts. So what? The point is are you saying something that somebody reasonable and fair-minded can interpret as anywhere near rational and logical? And my argument is no. And if we test 100 people, let them listen to Ken Wheeler, and then try to explain what Ken Wheeler just said, they will fail. And that's the test.
Can't think clearly. They're mathematicians. They're not actual academics. They're academics in mathematics, but they're not scientists. The scientist in Aristotelian Platonic sense is someone who quests for the answers to things, to truth, to wisdom, fundamentally the basis of truth.
Wisdom is the basis of truth? No, it's truth. Wisdom is made out of truth. Truth isn't the basis. Wisdom isn't the basis. Wisdom is the byproduct. When you got the truth, then you're wise. When you got bullshit, you're not so wise.
And check out this article below. If you could read it and see through their nonsense, I hope you're as tickled by it as I am. I love debating these people. I will never shy away from a debate with these.
Okay, he'll never shy away from a debate. So there's no evidence that he's ever debated anyone. There's no place you could find any debates with Ken Wheeler and anybody about physics. So there's no evidence of a debate ever. He claims he's not afraid. Well, I've politely asked him many times for a debate. Couldn't get anywhere. He blocked me for politely asking. He's a coward. And he just sitting here and lying, about how he's been he served his country in the war. I mean, you're a draft dodger, Ken. Okay, you're a coward.
People that are afraid to debate.
You're the one afraid. Now, obviously, regular physics, doesn't debate anybody. So that's just the way it is. But there's plenty of people who are willing to debate you, I'm sure, Ken. And I'm one of them.
But I have run across a few that were so full of themselves. They thought for sure they were going to beat this guy with tattoos. I got a PhD in physics. I'm going to thump this guy covered in tattoos. It's like, well, let's go there, girlfriend.
So why didn't it happen? So if they said they were going to beat you, why didn't it happen, Ken? See, he's just telling a story. He's just fibbing. He's a big fat fibber,
Let's have a debate on that, on magnetism. You know, I'm altogether too happy to entertain you on that one.
Yes, I'll defend their theory even if that was the rule of the debate, that all I do is defend the conventional theory, even though I think it's horseshit. It's so much better than Ken's theory.
Do it. Let's debate magnetism. Let us go there. Anyway, I look.
Yeah, okay. Well, how do you get that to happen except for you stopping it from happening? So there's no other obstacle than you to the debate happening.
That article to the person that sent it to me. I hope you enjoyed as well as I did. Lux Everitas.
Coward Fadius Bigius. Yeah, Cowardice Bigotus. Wimpius Whopperus. Yeah, you ought to change your name. Anyway, so I think that's all we need. I was going to use the wide image because, frankly, it's a pretty good image of... This is really what a magnet's doing. There's a force in the universe, pressure. Now, if you want to believe in an ether, that just means that there's bits of ether that are already perturbating, that they're already perturbating before they get to us. Okay, we don't need to perturbate them; they're already perturbated, and already there's little expansions in pressure that are already heading right for us. And there are two varieties: the pressure that reflects off of a proton and the pressure that reflects off of an electron. And a little inverse reaction happens when an electron force or perturbation hits a proton. It excretes in a different direction. And so the magnet, all it's doing is it's taking the pressure that's always out there, the pressure that creates gravity, and it's basically filtering the gravity and saying, look, all the red perturbations go this way and all the black perturbations go that way. And that's all the magnet's doing. It's just taking the energy already in existence, the perturbations already flying around, and it's just segregating the two. It doesn't make new ones, doesn't make any more energy, but by segregating it means that all the electrons are pushed by one side and all the protons are pushed by the other side. And that's the key to polarizing other materials. And when you polarize them, it has an effect. It creates electricity. It does lots of different things. All right. So, again, all I can do is reason with you people. My only weapon. I wish I had other. I wish I had a, Tesla's ray gun and could just, be a lot of fun, actually. A little disintegrator gun would be awful fun. Ooh. Yeah, I do get kind of a woo feeling thinking about it. All the good that can be done. Anyway, till next time and such.